Okay, let's talk about the vertical shift, which is the first of many transformations that we are going to perform on these parent functions. All right, so before we start transforming things, we need to know what is it that we're talking about. What is a transformation? All right, when we're talking about a transformation, we are talking about modifying a function to create a new function. Modifying a function to create a new function. All right, and when we are modifying, we do this by adding or subtracting, or multiplying, dividing. Okay, and we are doing this addition, subtraction, multiplying, dividing either to the input or to the output. Okay, so once we're messing with the input or the output, and depending on how we mess with it, it's going to determine how this function moves around. Okay, and so these parameters are used to shift or stretch our functions. So we can shift or stretch either to the left, right, up, down. All right, so this is sort of what we're working towards. So what are we allowed to do to a function? How can you transform a function? You can shift a function, which means move it left or right, up or down. All right, so shifting it takes the entire function, it keeps its shape, and it moves left, right, up, or down. You can stretch a function, which makes it larger horizontally or taller vertically. All right, so either wider or taller. You can compress a function, which makes it skinnier or shorter. Okay, and then you can reflect a function, and we can reflect over the x or y axis. Finally, let's just talk about what a parameter is, okay? A parameter is just a number that's inserted into the function. Number inserted into a function. Anytime you introduce a new number or a new parameter, your function is going to behave slightly differently. So when we're talking about we're going to change this parameter or this parameter, we're just changing different numbers within a function. So the first and sort of most basic parameter is to add something to the outside of a function. All right, we will form a new function g of x by taking our original function f of x and adding something to it. All right, so if my input is a -1 and f of x, which is this graph right here, f of x gives me an output of -2. So -1, -2 is on f of x. Well, g of x is going to be formed by taking f of x plus 4. This is also the same as g of x, okay? So instead of having -1 go to -2, I'm going to have -1 go to +2 because I took my f of x function and added 4 to it. At +1, my f of x value is here at 2. Well, my g of x is formed by adding 4 more to this, right? I'm going to add 4 to that 2. So this point up here is going to go to 6. At 3, right, my f of x function is back down at -2. I'm going to add 4 to this, and I get +2. So then at 3, my new value is +2. And at 5, my f of x value is 2. F of x plus 4, my y value plus 4 is going to be 6 again. So when x is 5, I'm up here at 6. So I get a new function that looks like this. I've just taken every y value and added 4 to it. Okay. What if instead of adding 4, I subtract 3? So now I have the same original f of x function here, but instead of adding 4, I'm going to subtract 3 at -1. My original value is -2. I'm going to subtract 3 and take that down to -5. At +1, my original value is 2. I'm going to subtract 3 and take that down to -1. Okay. At 3, my y value is -2. If I subtract 3, I'll go back down to -5. So I'll be here. And at 5, if I subtract 3, I'll end up at -1. So my g of x function here, if my parameter k is -3, all right, this is my red g of x, then that new function, this g of x function, will be shifted down like that. All right, so what you end up having is if you add 4, you're lifting your function up by 4. It's just going up. It's keeping the same shape, just shifting up 4 units. And if you're subtracting 3, you're taking that function and turning it into this red function. You're moving it down 3 units. So we can play this game with any function. We're going to usually use our 4 main parent functions that we went over. So let's look at the absolute value of x and then +2. Our parameter here is going to be a +2. So the original function, I'm going to graph here in blue. This is our parent function, what our function originally looked like. All right, and I'm going to call this parent function, this is f of x, the original. Now g of x is being formed by adding 2 to every point on f of x. So I'm going to graph g of x in red. So instead of 0, 0, I'm just going to take this point here and move it up to 0, 2. Instead of 1, 1, I'll be at 1, 3. Instead of 2, 2, I'll be at 2, 4. All right, so if I keep that pattern going, this red function, this g of x line on the right, will go like that. On the left, same game. -1, 1 becomes -1, 3. I'm just adding 2 to the original point. -2, 2. Sorry, I'm getting like things all over the place here. -2, 2. Sorry, this point down here is bothering me. It shouldn't be there. -2, 2 plus 2 is -2, 4 now. So I have this line on the left-hand side. So this red function is my g of x. It's taken my original parent function and moved it up 2. It added 2. Okay, we can do this to my square root function. So my parent function, again, I'm going to do it in blue. Looks like this. And you should get to a point where you know these parent functions pretty well, so you don't have to worry about the original graph, what it looks like. Okay, and now I'm going to take every point on that parent function and I'm going to move it down 3. My parameter is saying subtract 3. So instead of 0, 0, I'll start this at 0, -3. Instead of 1, 1, it'll be 1, -2. All right, 4, 2 becomes 4, -1. 9, 3 becomes 9, 1. Oops, not 9, 1, 9, 0. I'm subtracting 3, not 2. Boop. All right. So now I'm going to connect these points. And so my g of x function is my original parent function moved down 3. Finally, I'm going to play with this exponential function. All right, so again, I'm going to graph the parent function in blue. This is the original. It had a y-intercept at 1. All right, 2 to the first was 2. 2 squared was 4, 2 to the third was 8. It's exponential, it grows pretty quick. And on the left-hand side, it leveled off at y equals 0, the x-axis. All right, remember that this had an asymptote. All right, the x-axis was the asymptote. If I'm going to take everything on this original parent function, and I'm going to change the parameter. I'm going to add 1 to it. Well, what that's also going to do is it's going to take my original asymptote and it's going to move that asymptote up 1 also. So now for my new function, the asymptote will now be at 1 instead of at 0. Okay, my y-intercept is going to move up 1, and every other point on this graph is going to move up 1. So this goes up 1. So instead of hugging the line y equals 0, this is going to hug the line y equals 1. And then it's going to go up, and it's going to stay pretty close to this blue line, but everything will have moved up 1. All right, so the easiest way to move an exponential function is to move this asymptote, all right, and then you can also move the y-intercept. And then that sort of gives you an idea of where to start.